I'm gonna solve a very great question of limits. It involves a lot of advanced concepts. I mean, there's nothing such thing called advanced concepts, but yeah, they may increase the difficulty of questions by putting multiple concepts here. So let's try and solve the question. Well, I can see here that it has sine cube of something, like I call this theta for a moment, and like I think if I sum it like with the sine cube, it gets very difficult. So let me do one thing. We know the formula. Sine of 3 theta is equals to 3 sine theta minus 4 sine cube theta. So sine cube theta is equals to 3 sine theta minus sine 3 theta over 4. I'm gonna use this here. So let's see. So it becomes sine, or like this becomes 3 times of sine x by 3n minus sine of x over, or 3x over 3n, and then we have 3 to the power over 4. So I take constants like this. I think it's pretty perfect. It's a summation particularly from 1 to n. Let me just take out tn so that I could use my sequence and series concepts, because if I like do it rapidly here, it gotta get very complex. So tn can actually be to the power n minus 1 by 4 into 3 sine x by 3n minus times your sine of x over 3n minus 1. So that's become my tn, right? So I think this something looks like I gotta use the telescopic series here. Yeah, so I gotta rapidly put in the values and then check what happens. First of all, firstly I could do multiply this 3n minus 1 inside. So this becomes entirely 3n and this becomes 3n minus 1. So, and I can see the similarity in the angle of sine as well, that here is x over 3 to the power n and x over 3 to the power n minus 1. So this gives me a hint that consecutive terms will come. I put the values of 1, 2, 3, 4, assign the values of n, and then that they may cut down. And so I multiply it like this. It comes like 3 to the power n into sine of x over 3n minus 3 to the power n minus 1 sine of x over 3n minus 1. Yeah, so that basically comprises my tn. Now I write t1. So t1 is 3 sine x x over 3 minus 3 to the power 0. 3 to the power 0 sine of x over, so I put it at 1, it's 3 to the power 0, it becomes 3 to the power 0. Now again I write t2, so it comes down 3 to the power 2 sine of x over 3 to the power 2 minus 3 to the power 1 sine of x over 3 to the power 1. So I see that I can cross out the terms here. So I'll do it like that. Alright, tn, which will actually be 3 to the power n sine of x over 3 to the power n minus 3 to the power n minus 1 sine of x over 3 to the power n minus 1. I observe the pattern here. It gets cut down like this, like this, like this, like this, like this, and finally like this. And when I add up all those, I get Sn. So my Sn makes up like this. Sn equals to, so it comes like 3n sine of x over 3n minus sine of x. I gotta solve it further. Let's see what more was given in this question. I think we have solved this much part of the question. I gotta put limit outside the expression we have just evolved. So yeah, limit n tending to infinity. I can take 1/4 outside my limits, and then it comes down like, if I see this, the angle here, this angle is tending to 0, and so that makes me use like the concept sine x over x equals to 1 when x is tending to 0. So let's just do that. Yeah, it's 3 to the power n sine of x over 3 to the power n divided by x over 3 to the power n into x over 3 to the power n. That's cut down and that'll become 1 finally. I'm not just leaving it like here. And then sine x. And remember, many of the students make this mistake that they consider this x also as a variable, and they end up getting wrong answer, because actually the variable in this question is n and not x. Okay, let's move further. So I think after finally evaluating the limit, I think this was initially fx, so my fx comes like 1/4 times x minus sine x. Yeah, I'm sorry, this was an interruption in between. Sorry students, there was an interruption, so let me continue solving this problem for you. We had already got fx, and now, yeah, sorry for my accent though. Oh, there was something else going above. Yeah, so we need to see that gx is x minus 4 times of fx. So gx was 4 times x minus 4 times of fx. That implies x minus 4 times of x minus sine x. So gx comes sine x. Limit x tends to 0, 1 plus sine x raised to the power cot x, as that was what we were asked. So sine 0 is 0, so that 1 to the power infinity form. So we gotta check it here now. It comes e to the power limit x tends to 0, 1 plus sine x minus 1 times cot x. So let me just read this now. So sine x raised to the power cot x and limit x tending to 0. Sorry, why am I putting this here? It should be here. So this comes out to be cos x, and cos 0 is 1, so 1. Therefore our answer is e to the power cos 0, which is equals to e to the power 1.